let's go ahead and combine these two functions by using the operations addition, subtraction, multiplication, and division. And we're going to find their domain as well. So when we have the notation f plus g, well, that just means take your function f of x and add the function g of x, and you get another function. So in this case, our f of x is this formula, g of x is this formula. So we want to add them. So this would be f of x, which is x, plus g of x, which is square root of x. Now there's really nothing to do here because they're not like terms, because this you can think of it as x to the 1/2, and this is just x to the 1 power. So you can't really add them up. So we're going to claim that this is our answer for f plus g. Now what about the domain? So for the domain of f plus g, well, it has to be where both of these formula make sense. So the domain for f plus g is going to be where both of these two pieces make sense. So we see that for x, the domain is all real numbers. So there's no restriction on that one. For g, the domain is all positive numbers, including 0. So therefore, where both of them make sense will be from 0 to infinity. So the domain of this, you can draw it like this, starting from 0 all the way to infinity. So that would be our domain for f plus g, from 0 to infinity. Now let's go ahead and take a look at f minus g. So again, we'll do the same thing. We take our formulas and subtract them. So for f minus g, we're going to do f of x plus minus g of x. So we know f of x is x, so this is x. G of x is square root of x. We subtract the 2. And there's, again, nothing to do really because they're not like terms, so this will be the formula. Now the domain, again, where both of them make sense. Domain of this is all real numbers. Domain of this is from 0 to infinity. So they both make sense together from 0 to infinity. So domain for f minus g will still be 0 to infinity because that's where the two formula makes sense. Now for f times g, so for f times g, you can write it like that, or you can write just f of x times g of x. So where is f of x? Well, that's x, g of x, square root of x. So you can claim this is your answer, or if you want to write it in a different way by using laws of exponent, you can simplify. So this is x, and then square root of x is x to the 1/2. So when we multiply to same base, we add their powers. So 1 plus 1/2, that would be 3/2. So this is x to the 3/2. So you can also write it like this. In other words, you can also say this is square root of x to the 3rd power. That's another way to write the same thing. So now what's the domain of this piece? Well, again, because of the square root in here, it has to be 0 to infinity. So the domain for f times g is also 0 to infinity. That will be the domain of f times g. So you can see that all three of these has the same domain. Now for f over g, when we divide them, it's going to be a little bit different because we cannot divide by 0. So f over g, that will be f of x divided by g of x. So that's going to give us f of x, which is x, and g of x, that's square root of x. And if you want, you can simplify this since this formula can be simplified. So I can write x to the square root of x as x to the 1/2. So this is x over x to the 1/2. And then by laws of exponents, we can subtract the powers. So this is x to the 1 minus 1/2, which will be x to the positive 1/2. So our result simplifies to this function, or f over g. Now let's take a look at domain of this. So the domain for f over g, well, that's going to be, again, where both of them make sense, and also where g is not 0. So if you look at this formula right here, this was f over g. So when is g going to be 0? Well, g is the square root of x. So we know the square root of x cannot have, well, it goes from 0 to infinity, but we cannot have 0 on the denominator. So therefore, the domain has to be open at 0 to infinity. So that would be the domain for f over g. All right, so this is it. I hope this makes sense.